Wireless Network Security, Chapter 17. So in this one, since many of you may not have learned about A to 2.11, we teach about A to 2.11 in 473. And then we have a full course on wireless. But obviously nobody has taken the course in wireless here, but if you have taken 473 here, you know basics of 11, and I will go through that first little bit, and then we go into the first security method, WEP, which is actually not very much covered in the book, but that was then, it still exists though. I mean, most people probably today are using, you guys are using WEP still. And then we go to WPA, WPA2, which are the latest things which are discussed in the book in detail. And then we go to WAP and WTLS, which are in the book. So the way Wi-Fi works is that you have stations and you have access points. Access points, they periodically broadcast SSID, service ID. For example, an example of SSID is what? Anybody knows SSID name that you could use in this room? Huh? Wi-Fi, that's the SSID name. Alright? So SSID is broadcast, and the stations listen to these, and then they say, well, I know about Wi-Fi at this SSID, and then they send, and so there are many APs with many SSIDs, and only some you can join because you know them, others you don't know and you don't want to join, right? So you then get the access point that is broadcasting the SSID that you need, and you join. So sometimes the access points don't broadcast, and some people set up their network so that they don't broadcast. Okay, that's a security measure, by the way. If you want to be really secure, you don't broadcast your SSID. And then the people have to know that already. So if you know that there is a Wi-Fi in this room, and you have been told that, then you can just say, I want Wi-Fi. Okay? So a subscriber can send a probe to find APs in the neighborhood, and the APs authenticate the subscriber using shared keys. So that we will talk about as to how they authenticate. But then the station is authenticated, and then they exchange encrypted packet after that using that shared key. The subscriber station send a disassociate message and log off. And when you are done, you say I'm done, and you disassociate. All this is key because this is 1990s when the original Wi-Fi was designed. They did not understand cryptography as well. So first of all, one of the problems is, as you can see, that first of all, same key is known by all people. So you know the key, I know the key, and he knows the key, he knows the key. So it's like having a common password. Everybody has the same password, right? And then we use it all the time. So how secret it is? It's not secret at all. And then the encryption method they chose made it even less secure. It takes one message to decrypt it. And the integration method they used, the CRC, was such that you could change any message, and CRC, you could change the CRC as well. So everything was wrong with it. Anyway, I have put, if you want to learn a little more about Wi-Fi than what is in the book, Wikipedia is there to help. But basically, the access points are connected together by wired network, which is called a distribution system. Each access point serves a set of stations which are called basic service set. So there is one, there is another. These might be in the same SSID though, right? For example, all around the boostel, we have Wi-Fi. Right? These are different access points. So these are different basic service sets. The whole thing, and then in some cases, some stations don't have to join the access point, they can talk to the other stations. So that is called IBSS, where IBSS stands for Independent Basic Service Set. So this is called ad hoc network, computer to computer network, right? So whole thing is actually one extended service set, WFI. An extended service set is, all the base stations and stations that speak that SSID. So the service set ID, and I'm sorry, what is your name? Sorry. Are you paying attention to this class here? Okay, please close your computer unless you are really doing something related to this class in the computer. I think computer is coming in the way. All right, IBSS. So these are the terms that we used. First of all, there is a BSS and there is a basic service area. And so BSS relates to access point, where the area relates to basically in the same area there might be more than one access points, and they're all part of that same area, basically SSIDs. And then distributed set, and then the extended service area is the BSAs connected via the background. And then the extended service set is the set of stations, and IBSS is the ad hoc stations. And these networks can coexist and interoperate with infrastructure-based networks. So when you have an access point, that is called infrastructure-based network. And when you don't have an access point, that is called ad hoc network. Right? And so it is quite possible that you could have some stations that would let you connect via WFI, but I don't think there are any in this university. So basically, generally the ad hoc stations will have their own SSID. For example, you can connect your phone to your computer using an ad hoc network, right? And so these might exist separately, although theoretically it is possible that some station could offer the service for you to send your thing through the station to the access point to the world. Yeah. So infrastructure means that somebody has put the network in place before you came in, which means access points. Infrastructure means access points, period. If there were no access points, then how do you connect? You connect two computers by ad hoc. So that is not infrastructure based. Now, association means connecting. Disassociation means disconnecting. And why association is important? Because it is during the association that you provide the secret keys and things like that. Negotiate the keys, right? Now your turn. You, please close the computer. Are you reading on Wikipedia or something or what? Yeah. Because your actions were not in sync with my actions, and so I noticed that, and so I didn't know what you're doing. But please, okay, that's all right, and that's okay. Yeah, go ahead, next.
What is the STA?
STA, okay, what is STA? STA is station. AP is access point. So I will use the word STA throughout this lecture, and thank you for asking. Disassociation is termination of association. Yeah, we said that. And reassociation is you go from one access point to the next access point. And the mobility could be between inside the same DSS, or it could be within ESS, within the same ESS, or it could be between two ESSs. And generally it is not even supported. I mean, it is difficult to get that within ESS itself, let alone within two SSS. Okay? And the reason is not wireless, but the problem is IP. Because when you move from one area to the next, for example, you go from here to the library, the address, IP address may change. Once you change your IP address, all your transport connections are broken. And so everything has to start from the beginning. All right, MSDU delivery, MSDU. Service delivery, SDU is service data unit, right? And MAC layer service data unit, MSDU is basically data link, L2 or the layer 2 service delivery unit. Now, I don't know if anybody knows the difference between SDU and PDU. Anybody knows here? SDU, what is PDU anyway? And you should know, because if I just start this in 473. Huh? Yeah, protocol data unit. And SDU is service data unit. What is the difference between the two? Service comes from the top and protocol goes horizontal. Now here's the thing, when I teach this in 473, this is not in the books. And the book guys, they are too much IP oriented and they don't teach this stuff because this is all ISO stuff. And then the student then write in the review saying that, oh, you taught me all this ISO stuff and this is totally useless, not useful to me. Well, they don't understand that next year you will need all that. SDU, PDU, some students actually complain in the reviews. Whole thing, everything about ISO. But this is really, we need it, that's why I teach you. I know that in the next class you will need SDU. So SDU and PDU is the protocol data unit, and then each layer has a protocol data unit. For example, TCP has segments, IP has datagrams, Ethernet has frames, applications have their own PDUs. So those are the PDUs which go from application to application, transport to transport, from this end to that end, right? SDUs are the messages that flow downwards. So what the application gives to transport is called transport SDU. What the transport gives to the network is called network SDU, network service data unit, something that enters at the network service door. So network, this is network, and whatever comes in from the transport is called network service data unit. Now, network will take that NSDU and break into many PDUs, right, to send to the other side. So anyway, this is MSDU is the MAC layer service data unit, and that is the packets that go between the STAs or STAs and R and X, between STAs, R, even STAs and access point. Actually, I mean, there is nothing which really goes between the STAs. If you want to, I want to talk to you, I send it to the access point and access point sends to you normally. Now, in the newer versions of Wi-Fi, they are allowing direct transfer, where some time will be reserved for two stations to transfer. Otherwise, you just ask the access point, can I send it? And the access point receives it, and then it sends to the receiver. So there are two hops. All right? And in the newer versions, they allow direct transfer, where you say access point, I want to transfer something for the next 5 millisecond or 5 microsecond, and then it says okay, and then you transfer it directly there. So you save one hop for long messages. All right. So delivery. Distribution. Now distribution is the delivery over the wired network. So this is the distribution. So if you want to send a packet from here to there, it will go through the distribution system. Integration. Interchange of packets between the STAs and the wired connection station. So integration means you are not just limited to wireless, you could talk to people who are not on the wireless server. This server is not on the wireless, but it is reachable by any unit here, right? Because it is going through the distribution system and then going to the wired network. So that is integration. And we already talked about IBSS, which is the independent basic service set, and we talked about the ad hoc, which is basically IBSS, and they can coexist with wired networks. So these are the terms we use. And looks like we already talked about, yeah, I'm sorry, we got backwards. Okay, so we talked about authentication, integration, de-authentication, and privacy. Now, notice it says authentication, the station is authenticated. So in the original days, we thought that the servers cannot do any problem mistakes. They cannot be a problem. So only the station was authenticated. We didn't authenticate the servers. So what is the problem with that? Anybody can think of any problem if you don't authenticate the server? Yeah, somebody could just put an access point and say, I am Boofy, give me your password. Right? So now the world has changed. We have to authenticate the bank. Not only the bank authenticates you, you authenticate the bank. So now it is mutual authentication. Anyway, so WEP. Now WEP is the old system again. And the reason it is important to learn about it is so that not to make the same mistake. If you are developing a new protocol, new system, new something, you need to learn from this. So I am adding this WEP little more detail than it is in the book. WEP stands for Wired Equivalent Privacy. So the intent was that you will get as much privacy as you get on a wired network. If something you do not get on the wired network, obviously we are not going to provide you on the wireless network. Wireless cannot be stronger than wired network, right? But it has to be as good as a wired network. So as good as a wired network, that's what WEP stands for. Privacy similar to a wired network. And intellectual property is not exposed to a casual browser. It does not protect from a hacker. Yeah, so that was the idea, that a hacker can come in on your wired network and attack you. So can they do here too, but that is not expected from the network, not at least in those days. So this was the first encryption standard that was defined in 82.11b, and it provides authentication and encryption. By the way, 11b is not the first standard. 11b is the second standard. The first standard was 11. You don't use 11 anymore. But 11 provided 1 megabit. And soon people felt that that was too low, so they increased the speed to 2 megabit, and that is what 11b is. Sorry. No. 1 provided 1 and 2 megabit. B provides 11 megabits. Sorry, 11 megabits. So B is 11 megabits. And then they had A and G, which provided 54 megabit. And now they have N, which provides 200 megabits. And then they are going to have the next one, I don't remember the number, is going to provide 1 gigabit. Right? So we are moving up the scale, and so B is the second standard. So today the lowest B used is B, 11 megabits. So it was this was defined in that one. It provides authentication and encryption. And by authentication I mean both actually. It provides the user authentication, just means password and all that, but it also provides MAC, integrity. So shared key authentication. The main problem was that a single key is shared by all users and access points. Two modes of authentication, open system and shared key. And so basically open system means anybody can come in, shared key means you know the key. So obviously open means no protection. Shared key is challenge response verifies that the client has the key. And so for the shared key, they were smart enough to think that at least we should not send the key in open. So they said, okay, here are my nonce, give me the encrypted version of this nonce. Alright, if you know the key, you can give me the correct encrypted version, and they thought that was good enough. And the main thing was that they didn't realize that they were using RC4. RC4, if you remember RC4, now I don't think anybody ever remember. Anybody remembers what is RC4? What does it do? Huh? Yeah, RC4 is Ron's code. Anything else you remember? Yeah, and then do you remember whether it is stream code or whether it is a block code? Stream code. So in the stream code, all you do is you take the encrypted message and you take a keypad and you exclusive or you can send it. Now you take your private, you take your not encrypted message. You take a plain text and you take the keypad, your one time whatever the stream, and your exclusive R, and that becomes your ciphertext. Right? So here is the interesting part is that, so you send the nonce is sent in clear. So here is my nonce, and the encrypted text is sent then back. If you take the nonce and the encrypted text, what can you find out? You can find out that key stream. And then anytime anybody, any station sends you any other nonce, you can validate yourself. Right? So it was very weak. The second problem was manual key distribution. So you have to basically go to the office and say what are the keys, and they give you the keys on a piece of paper and you put it in your computer. If an adapter or access point is lost, all devices must be rekeyed. So if one employee leaves, then everybody gets a new key, because that key is no good. Right away there is a problem for big companies. And since they didn't have one key, so they said, okay, well, let's put 4 keys. Just in case one person leaves, we can just disable that one key. But anyway, so they had 4 keys, which really didn't have too much, but they had 4 keys, and they are manually programmed, and they had a 24-bit IV. IV is the initialization vector. And the WEP key is used to form a 64 key. So basically you use your WEP key and a 24-bit IV. So you have 40-bit here and 24-bit there, total 64-bit. Or you could somehow get 104-bit and 24-bit to make 128-bit RC4 key. So you would use either 64-bit RC4 if you are having an exportable device. If you had a non-exportable device, you could use 128-bit RC4. And the key stream is generated using that key. And then for message authentication, all they had was CRC, 32-bit CRC. So if somebody changed the text, the CRC will not match. And then the plain text and the key stream is exclusive ARD. Okay, so these two things are exclusive ARD, and then 32-bit CRC is added in the clear. So the integrity check was outside the ciphertext, not even inside. All right. So now you can see, basically the kinds of problems you run into. First of all, no centralized key management. So manual key distribution. That means everybody had to get a piece of paper, and that's not what we want to do in these days. So it was difficult to change keys. Single set of keys shared by all. That was not good. No mutual authentication. So there were lots of what we call rogue access points. Basically, people will set up an access point and get all your passwords. And that happens even today. So that is one of the things that you have to do when you join a company and you are a security officer. You have to keep looking around your area as to how many access points there are. What are they doing? Has some employee set up an access point themselves? Because these are all trapdoors. Somebody could just set an access point and somebody outside is getting all the messages through that wireless. All right. So no user management means there was no radius, right? So the book uses the word radius without defining. Now you know what radius is. IV value is too short. 24-bit is, you can try all possible IV values very easily. 24-bit is not good enough. And not protected from reuse, because if you are going to use IV one after another, you will run out of the IV again. Weak integrity check, that CRC is not really good at all. And directly uses master key. And then you use the key all the time, same key. Right? So it's not that you negotiate a key and then derive a key or anything like that. No protection against replay, there is no sequence number and things like that. So now can you believe this was designed by the security experts of those days? Right? So they were all security experts, but not by today's standard. These are beginning days of security. And I think this might even be around the same time that SSL, etc. were being discovered. 90s, early 90s. SSL was not there probably. Anyway, so now we come to the book. So the book talks about WPA and WPA2. Actually, the book doesn't even talk about WPA because they straight away jump into WPA2. And I don't know how many of you are using WPA2. Most of you are using WPA. So what is WPA? What is WPA2? Basically, the wireless guys got together in Wi-Fi Alliance, which is a company group, a group of basically organization, and they designed a secure method and they proposed it to IEEE, and that standard is called 802.11i. So 802.11i is the standard for wireless security. However, the changes that were required would put all the current infrastructure useless if they insisted that you have to use that new standard. The new standard required new hardware. So they also developed an intermediate standard, which is actually described in 11i, but it is said that don't use it. All right, but you use it because that's the only way to talk to old stations. So that is software upgrade. So software upgrade of WEP is called WPA. So Wi-Fi protected access. And all the software you can do is you can so these are the four things they're doing. First of all, they use per packet key. So you don't use the master key all the time. You generate a key for the packet and don't use it again. Generate another key for the packet, don't use it again. It's easy to do in the software, right? They still use the same RC4. So that they could not change because that they wanted to change, and that would require a new hardware. So they already had this code, but they used a per packet key. They added a sequence number, so you could not replay. And they changed the CRC part. They changed the integrity check MIT. And the integrity check is called message integrity check, 64-bit, so it's not 32-bit. And so anyway, so all these changes made it stronger, and WPA is strong enough that most of us really, can use it securely. Of course, Defense Department would not find it useful, but for normal business use, WPA is good enough right now. And if you are really concerned about it, then you go to WPA2. That means you buy all new laptops and new access points. Okay. Now WPA2, on the other hand, uses the latest in encryption, which is AES with counter mode, and it uses for integrity, it uses the counter mode again, AES with counter mode. So it uses that CCMP. It is called counter mode with cipher block chaining, which basically you know already all this. So this is called CCMP. By the way, this is called TKIP, the first part, WPA. Another name for WPA is TKIP, and that will be coming up in a minute. TKIP stands for Temporal Key Integrity Protocol, TKIP. And this is called CCMP. The whole thing is called CCMP. Alright, so there are three methods of protection on Wi-Fi. WEP you should not use at all, even in your home. WPA is good enough for your home. WPA2 is good if you really care for security. Yeah.
So the machine with the WPA2 hardware communicate with WPA?
Okay, so everybody is designed to communicate with everything. So a machine that speaks WPA2 probably speaks WPA and WEP and open, right? However, you at the access point have the option of disabling some things. So you would disable open access, you would disable WEP, you would disable WPA. If you do all those three things, you got WPA2 system, right? The laptop can speak all four. The new laptop can speak all four. The old laptop can speak only one or two. Yeah, the oldest laptop can speak only WEP, right? But then you go and get a driver upgrade right? That will make you WPA. All right. So now let's go into WPA2. There are 5 phases. There is discovery, there is authentication, there is key management, and there is protected data transfer, and then the connection termination. By the way, before I continue on WPA2, the homework for this actually is related to WEP, and I think it might be just good, because that could be, I mean, WEP is already covered here, is that you are able to do the homework for sure. And so the homework, I'm going to skip to the homework and then come back to here. The homework says, WEP assume that all devices share a secret key. The purpose of the authentication scenario is to prove that you have the secret key. So you send a request that I want to join, and then it gets a challenge, and you send a response, and you get a success, right? All right. So the STA sends a message requesting authentication. The access point executes a challenge, which is a sequence of 128 random bytes sent as plain text. The STA encrypts the shared key and returns it to the access point. So this is the challenge, and this is the response. The AP describes the incoming value and compares it to the challenge that it sent. If there is a match, it says you are fine, right? So the question is, this authentication scheme is one-sided. How can it be made mutual? Right? It doesn't authenticate the access point at all. Right? So the question is, now I won't give you the answer here, but the question is, how can you make it two-sided? So you need to add some messages to it. Right? Second thing is, what information does it provide to an attacker, making it easy to attack? So is there a way that the attacker can get the keys, and how can they use it again? I already told you that if you listen carefully. Answer to that one. Then the encryption scheme is RC4 stream cipher, which is actually not very strong. So RC4, how can an attacker create a valid response for any challenge after watching just one valid authentication? So right, I mean, you just get one challenge and one response, and then you are good for others. So all that, I have said it, and most of you probably listened. Some of you were not listening, so you didn't listen, but this is the homework. Okay, related to that. Now we go back to WPA. So there are 5 phases: discovery, authentication, management, transfer, and the connection termination. Discovery is, as we said here, except that the, let's see, first you send, may I join, then you can say yes you can, then it says okay, here is my request to join, it says no. You have to send me this particular method, and then you send that particular method use, and then they send you that these are the things that we'll talk about. So all of this is encrypted after that. So capability negotiation. So what it does is, in the discovery phase, you negotiate what you can speak and what I can speak. So in this message, this null response, the access point says I can speak WEP, PKIP, CCMP, or I can speak Cisco, right? And then the access, and then the laptop will say, okay, I can speak Cisco also, and so then you select that and use that. So that is the capability negotiation and integrity. So basically the same thing you do for the MIC. Authentication, then methods allowed are 802.1x. Now if anybody remembers what is 802.1x. Anybody remembers what is 802.1x? Huh? 1x. When was it discussed? Was it discussed recently? When? Oh, come on, guys. It was discussed on Monday. Whole chapter AAA was about 802.1x and radius. Just last class. All right, and that's why I discussed it before this, because we are going to use all these terms. We are going to use EAP, we are going to use 802.1x, we already used radius. All these terms are used in the book without defining clearly. So I said, let's put one class extra for that. So the last lecture, if you go back to 23, which is actually slightly difficult to read because it's not in the book, but I put on every page Wikipedia references. So if anybody bothered to go to the Wikipedia, they would remember what is 802.1x, what is radius, what is E. Anyway, so we negotiate whether you want to do by 802.1x, pre-shared keys or vendor specific again. Each vendor has their own method. All right, so all that is done in the discovery phase. And so after this phase is done, we know exactly that you can speak CCMP and that you can do 802.1x or not. And we agree on common thing. Now I put here 802.1x again, just in case, But this is the slide which was already presented in the last one, in the last lecture. So this is a duplicate of 23. Basically what 802.1x does is that whenever somebody connects, they cannot talk to anybody in the network except the authenticator, which in this case is access point. And once they have been authenticated, then they can talk to anybody in the network, and that includes the access point as well. And this is again a replication of the previous slide. We had talked about this 802.1x. I just copied the same slide again here. Is that you send a message, and in this case, if you had a radius server, then basically the message will go to all the way to there. So it will say, can I associate? It says, okay, tell me who you are. Then you say, this is me. Then you send it to the authentication server. Authentication server says, well, he can be authenticated by whatever method. And so he sends a request and you send a response, and then it says a success. So it all matches, and then the access point simply has to know what? Does it need to know? In this case, if you speak 802.1x and EAP, then it doesn't need to know any of the methods, authentication methods. It doesn't need to know AES, it doesn't need to know anything else. Right? Not for authentication, because authentication server takes care of that, and the access point simply reads the code. Right? The code is success means gone, then yeah. Okay, so there is no password transferred in, right? As I said, in 802.1x, however so there is no password transmitted anywhere these days. Basically, in 802.1x, if you were going to be authenticated by password, so you will say, I'm John, and I will go to the WTLS key server. WTLS key server will send you a challenge, which you will encrypt with your password or hash of your password and send it back. Right?
But I guess maybe a better question is, how are these initially set up? Like, how does authentication server initially?
Oh, that is actually, yeah. So basically, how was your WTLS key set up? I mean, the way your WTLS key was set up is that you made a request to your management, and they sent you a random password or some initial password and asked you to change it right away, something like that. And so generally they don't send you by email, they just call you on the phone and tell you your initial password. So that is how it will be set up on the radius server. So your WTLS key actually is a radius server, right? Most likely. All right, I will stop right here. And so clearly 802.1x authentication is in the exam because it is in the previous chapter, and so we will stop right at this slide. Wi-Fi WEP is in the exam.